All right, welcome. Let's do some telescoping series examples, okay? You know this is not an AP Calculus topic, but maybe you're just interested in this series, or this type of series, and, well, here I've got a few examples for you. So I'm specifically, if you're in my class, I'm working number 8 from BC Homework 11.1, and it's got 5 series that I think are telescoping. I'm not entirely sure. I assume they are because they're labeled that way. And I'm going to say, all right. The first of them is the sum as n runs from 2 up to infinity of 1 over n squared minus 1. Okay, this is going to be one that I got to break it apart using partial fractions. Okay, and that's part of the reason why I show you all this in the first place, is just to give you another reason to break apart a fraction into partial fractions besides anti-differentiating it. Okay, so I'm going to just say, all right, I know that, I think I'm going to do my partial fractions work over here on the side. I know that 1 over n squared minus 1, n squared minus 1 can factor into n plus 1 and n minus 1. So I'm going to call that some number over n minus 1 plus some other number over n plus 1. Okay? And then I can multiply both sides of this equation by n plus 1 and n minus 1, and I can say that at 1 is equal to a times n plus 1, and b times n minus 1. Okay? Then I'm going to let n equal positive 1, and I'll get 1 equals 2a. That tells me a is a half. Okay, then I can let n equal negative 1, and that will tell me 1 is equal to negative 2b, meaning b is negative 1/2. Okay. So I've got it all set up. I'm just going to rewrite this series as the sum from 2 to infinity of 1/2 divided by n minus 1 minus 1/2 over n plus 1. Okay. If you wanted to, you could factor out the halves, right? Say it's a half of the sum of 1 over n minus 1 minus 1 over n plus 1. That may have been the smart thing to do, but I think I'm just going to hold on to those halves right where they are. Okay, at this point, if you see, oh, this might be telescoping, right? I might have a situation where n plus 1 now equals n plus 1 later, or n plus 1 now equals n minus 1 later, I think is more likely. If you know how these go. So we're going to then go forward and write out some terms. Okay, so we're going to start at n equals 2. So when n equals 2, I've got 1/2 over 1 minus 1/2 over 3 plus, okay, and then the next one, I'm going to have n equals 3, and I'll have 1/2 over 2 minus 1/2 over, well, when n equals 3, that's 4. Like, dude, is this ever going to actually telescope? And, well, I hope it does. Not really sure what's going to, oh, I see what's going to happen here, yeah. All right. Now, I've got, when this was n equals 2, that's n equals 3. The next one will be n equals 4, so it'll be 1/2 over 3. It's like, now I got one that's going to cancel. Okay, minus 1/2 over n plus 1 is going to be 5, right? Okay, and I don't know, maybe because this is the first one, I'll write out a couple more terms just so we can see what's going on. I can see what's happening here, but I'm not sure that you can. So n equals 2, n equals 3, n equals 4, next one's n equals 5. So this is divided by 4 minus divided by 6. Okay, both numerators of half. Do one more, just so we can really see what's going on. So this was n equals 2, 3, 4, 5. N equals 6 will give me 5 and 7 as my denominators. Numerator still half. And I think I'm going to put the dot, dot, dot there. Okay, now I'm ready to go. I'm ready to start killing stuff off. So I've got, here's the first overlap. Positive 1/2 divided by 3, negative 1/2 divided by 3. Negative 1/2 divided by 4, positive 1/2 divided by 4. The 5s, they're going to cancel off. Later on, I'm going to get a positive 1/2 over 6 and a positive 1/2 over 7. So those are all gone. Everything is gone except for these. So I've got a half plus a fourth is going to equal 3/4. Well, the second one, I've got the sum from n equals 1 up to infinity of 1 over 2 to the n minus 1 over 3 to the n. I am not sure about this one. Is this even telescoping? We'll find out. Oh boy, I almost tricked myself. I guess this is not exactly a telescoping series, although it does kind of look like one. Yeah, if we actually listed out the terms, I don't think that we would find that they would cancel off, right? Because powers of 2 are not powers of 3. So like this negativity here, I'm not going to actually be able to subtract anything. But what I can do is I can say, all right, hold up. I know how to do this. Right, that's a geometric series. Uh-oh. This, also a geometric series. So I'm going to find their totals and I'm going to subtract them, right? Because all the positive terms in this series are going to be 1 over 2 to the n, which would add up to this. All the negative terms, if I factored out the negative against those terms, I'd have just 1 over 3 to the n. So I'm just going to find these separately and then subtract them. Okay, so 1 over 2 to the n, first term is going to be 1/2. 1 over 1 minus the common ratio is also a half. Okay, so that's going to be 1. Okay, oh yeah, we've already solved that series in this class. All right, then this one is going to be first term is 1/3. 1 over 1 minus 1/3. All right, if I take 1 minus 1/3, that's 2/3. If I take 1 divided by 2/3, that's like multiplying by 3/2. So 1/3 times 3/2 is equal to 1/2. Okay. Now I can say that this total sum is going to equal 1 minus 1/2, and that's going to equal 1/2. Okay, so that wasn't a telescoping series, but I guess it looked like one, and we need to, I don't know about need. In AP Calculus, I don't think they would ask you to do that. They're much more direct with their lines of questioning. So the third one is definitely going to be a telescoper. I can tell because I'm looking at it, and it looks very factorable. I need a couple more sheets of paper. Get something to write on here. Okay. So the third example is going to be the sum as n runs from 2 to infinity of 2 over n squared, 6n, and 8. Yeah, that's factorable. That's going to be n plus 4, n plus 2. So I am ready to split that up. Okay, so I'm going to go over here to do my partial fraction work. So I'm going to say that 2 divided by n plus 4 and n plus 2 will equal some number divided by n plus 2 plus some other number divided by n plus 4. Okay, I'm going to clear out the denominators. I'm going to say, all right, 2 equals a times n plus 4 and b times n plus. If I let n equal -2, I'll get 2 equals 2a, so that feels like a equals 1. And if n is equal to -4, then I'll get 2 is equal to -2b. That means that b equals -1. If that positive and that negative, that's a pretty good sign. Okay. So now I'm going to say now this series has become the sum from 2 to infinity of a is 1 over n plus 2, minus 1 over n plus 4. All right. And now I'm ready to start writing out terms. Okay, start with n equals 2, so I've got a 4th minus a 6th. That's my first term. Plus my second term will be n equals 3. It's a 5th and minus a 7th. Okay, n equals 4. N equals 5. And so on. Okay. And now I'm going to start canceling off terms, right? I should be seeing I see the 7ths. They're going. The 6ths. They're going. The 8ths would go with the next term. The 9th would go later on. Okay, so they're all eventually going to get killed off. And now I've got a fourth plus a fifth, and 1/4 is 5/20. 1/5 is 4/20. So in total, I have 9/20. Okay. This next one, okay, again, it kind of looks like one that would potentially, I don't know how, this one would not be a telescoper though. N equals 1, running up to infinity of 0.7 to the n plus 0.9 to the n. Okay. This is going to be the sum of two geometric series, both of which I can compute the value of. Okay, so I'm going to say the sum from 1 to infinity of 0.7 to the n is going to be, okay, the first term is 0.7, that's 7/10. Common ratio, also 0.7, so 1/1 minus 7/10. Okay. That's going to be, let's see what's going on here. 1 minus 7/10 is 3/10. So it's like multiplying by 10/3, and so that's 7/3. Okay. The other one is the sum from 1 to infinity of 0.9 to the n. Okay, the first term is 0.9, that's 9/10. Times 1/1 minus 9/10 is the common ratio. So I am, what am I thinking here? 1 minus 9/10 is 1/10. 1 divided by a tenth is 10. So I got 9/10 multiplied by 10, that's going to be 9. Okay. So in total, I've got 7/3 plus 9. 9 would be 27/3. So in total, I've got 34/3. And one more telescoper. Now, I hope that this one works out, but who knows, maybe it diverges or something. It'll be something different. But I think you can tell, like, for the most part, these telescoping series, they're pretty predictable and they're not that exciting. You would just need to know to break them apart using partial fractions. So this is the sum as n runs from 0. Oh, okay, that's fine, yeah. To infinity of 1/n squared, 9n, and 20. Okay, so it's like, oh, that's factorable, n plus 5, n plus 4. Okay. So let's go over here and let's do that. I'm going to say that 1/n plus 4, n plus 5 is equal to some number divided by n plus 4 plus some other number divided by n plus 5. I can, hold on, what's going on here? Oh, yeah, clear out the denominator. Okay, let n equal -4. That gives me 1 equals a. N equals -5. That gives me 1 equals -b. Okay. So b equals -1. Okay, so this is set up really well to be a telescoping series, and I mean, I think it's going to work because we've got the negative in the middle and increasing denominators. So that's the sum from 0 to infinity of 1/n plus 4 minus 1/n plus 5. And then I'm going to, what am I going to do here? Oh, yeah. I'm going to start writing out some terms. When n equals 0, I've got 1/4 minus 1/5. When n equals 1, I got 1/5 minus 1/6. When n equals 2, I've got 1/6 minus 1/7. And I think that's going to be enough, right? Enough for us to see the pattern at least. Okay, the 5ths are canceling, the 6ths are canceling, the 7ths will cancel, all the rest of them will cancel. This total is 1/4. And that's going to be all I got for you for this video. That's the telescoping series, which, again, I just want to emphasize this is not an AP Calculus topic, but it's something I just like to include in my calculus class because it's just a different type of series that we can find the value converges to.